So a couple of notes. First of all, it does turn out, number one, that f of x equals log base a of x. It is a function. If you graph it, it will pass the vertical line test. And we'll graph one of these later on. You'll see that at least that one will pass the vertical line test. And that means that the log, as defined here, is a function. So x is, when you define it this way, the input is what comes after the log base a. Remember, this is not a to the x. The input is x. The output is f of x, the way it's written here. So that does turn out to be a function. And interestingly enough, y equals log base a of x and y equals a to the x are inverse functions. Huh? Oh, wait a minute. Okay, what is this guy again in exponential form? Y equals log base a of x is the same as saying a to the, what's the exponent? Y equals x. So now compare that, a to the y equals x, with y equals a to the x. What's the difference? X and y are switched by definition. As long as they're both 1 to 1, which they are, these guys are inverses. But the exponential form, but the exponential form a to the y equals x is just an alternative form to y equals log base a of x. So that means y equals log base a of x, y equals a to the x, they're inverse functions. That's very important, actually. That's why we study logarithms for the most part. Okay, in this example, let's graph y equals log base 2 of x. And I just note here that that's the inverse of y equals 2 to the x, which we graphed last week, remember. So we're essentially graphing the inverse of the exponential function y equals 2 to the x when we graph y equals log base 2 of x. So you don't know a whole lot about logarithms, except you do know how to convert forms. So what could you do if you want to graph this by hand? Yeah, go ahead and rewrite it in exponential form. So that's 2 to the what equals what? 2 to the y equals x. And let's plot. So notice it is, in fact, the inverse then, because the x and the y are switched around, aren't they? So let's go ahead and make a table. X, y, but you're used to making your input x. And in fact, when you have it in log form, the input is x. But when it's in exponential form, you're not going to want to think of the input as being x, are you? Yeah, you'd want to plug in for y, because if you plugged in for x, you'd have to solve for y, which may not be easy. So plug in, what would be some good y values to plug in? 1 would definitely be good. 0. We can plug in -1. We can plug in -2 just for the sake of argument. 2, oh, that's good. Okay, do you guys remember what happens when we plug in? So we're plugging in for y. So 2 to the -2, what is that? It's the same as 1 over 2 to the positive 2, which is 1/4. Remember that? Does that make sense? The negative in the exponent means take the reciprocal, right? If you want to lose the negative. Okay, so then what would, if we plug in, so that's the x value, 1/4 is the exponent value. So that's what we did. We just plugged in, I turned this statement around and said x equals 2 to the -2 is what we plugged in. What if we plug in -1? 2 to the -1 is what? Yeah, it's 1 over 2 to the positive 1, which is just 1/2. What happens when we plug in 0 for y? 2 to the 0 power is 1. What happens when we plug in 1 for y? 2. What happens when we plug in 2 for y? 4. Now, when you have a chance, go back and look at your notes from last week. When we graphed y equals 2 to the x, I'll bet we plotted exactly the reverse ordered pairs. Because the inputs for y equals 2 to the x, it would be convenient, just like the inputs here were y, it would be convenient to use the same inputs here, -2, -1, 0, 1, and 2. So I'll bet if you go back and look at your notes, we got exactly these ordered pairs except reversed. Okay, so let me plot these things. So at 1/4, we're down -2, so there's a half on the x. down, -2, and then we got to go a quarter, so half of a half right about there. Okay, and then go over 1/2 down 1. Okay. And then 1, 0 is easy enough to plot. Over 2 up 1. Over 4, 1, 2, 3, 4 up 2. Now before I connect the dots, there's a line that this thing's not going to cross. Does anybody see what it is?
Y = 0.
Well, it's actually x = 0. It's the y-axis. And that's because, right. So the equation of the y-axis is actually x = 0. The equation of any vertical line is x equals whatever the horizontal position is. In this case, the horizontal position of the y-axis is 0. Does everybody see why that's true? Look at the second column in the guys we plotted over here, which is, a subset of the range of the log function. But you can see what's happening just from that. There's nothing you can plug in for y. So these values over here, no matter what you plug in for y, they make these values over here they're positive. Let me kind of back up. What I meant to say is there's nothing you can plug in for y to make the x values negative, right? They're all going to be positive. Either fractional powers of 2. If you plug in 0, you get 1. If you plug in 1 for y, you get 2. 2 for y, you get 4. Or so either fractional powers of 2 for x or powers of 2, right? Or some ugly decimal. If you plug in a decimal value for y, you'll get a positive value for x. It'll be some ugly decimal though. So that means that x will never be, let alone 0, it'll never be less than 0. So I'll kind of cross out that less than sign. And you can kind of see that from the table, right? So that means that x = 0, what do we call that? Yeah, it would be a vertical asymptote. It is a vertical asymptote. So if you want to draw that, I'll just use a dotted line, dashed line, I guess. That's x = 0. So when you draw it, make sure the graph doesn't cross it. So it'll get closer and closer. As x gets closer to 0, it'll get closer and closer and shoot downwards. So the graph doesn't stop here. It keeps going. Use a little arrow to indicate that. It's a nice smooth curve. And it'll keep going up as x goes to the right. It'll keep rising as x goes to the right. If I can get the trajectory correct. Should be a nice smooth curve. The problem is I'm not straight. Okay. That's a little better. Keeps going up. So put a little arrow to indicate that. So by the way, does it pass the vertical line test?
Yes.
Yep. So it is a function, y = log base 2 of x. So that's what this is the graph of, y = log base 2 of x. It is a function, and furthermore, it's 1-to-1. What other test does it pass? Horizontal line test. So it's 1-to-1. So not only is it a function, it's a 1-to-1 function, so it's going to have an inverse. And as we already said, its inverse is y = 2 to the x.